Knot theory is the mathematical study of knots and is nothing like the maths you learned in high school. Take a piece of string, tie a knot in it, then join the ends together. No matter how much you wriggle this string around, the knot that you tied can't come undone, unless you didn't actually tie a knot in the first place. Now, if I asked you to tie a nice simple knot, there's a very good chance that you would tie this one. Once we join the ends together, we can wriggle it around in different ways and make it look completely different. But somehow we know that it's still fundamentally the same knot. See if you can convince yourself that the bottom left and bottom right knots are actually the same. This is one of the fundamental problems in knot theory. How do we know if two knots that look completely different are actually the same? It turns out that we can use maths to answer this question. Any information that you can take from a knot that doesn't change when you wriggle it around is called a knot invariant. It is something inherent about a knot that doesn't vary, some fundamental unchangeable property. There are many knot invariants. Some knot invariants are very easy to calculate, but they don't tell us anything very interesting about the knot. On the other hand, some knot invariants are incredibly difficult to calculate, but make up for it by capturing a lot of information. I study a knot invariant that falls into the latter category. It is called the A-Polynomial, and to the untrained eye, it just looks like a string of letters and numbers. However, different knots have different A-Polynomials, and what's more, by studying this string of letters and numbers, we learn things about the knot that few other knot invariants can tell us. The aim of my thesis is to make it easier to calculate A-Polynomials so that we can more readily access the powerful information they carry about a knot. One thing that really excites me about research in pure mathematics is the connections being made between fields that were previously believed to be entirely unrelated. My supervisors and I have made progress towards simplifying the calculation of A-Polynomials by observing a connection to something called a cluster algebra. Using results from cluster algebras, I have been able to write down formulas for A-Polynomials of infinitely many different knots. Cluster algebras are also associated with another knot invariant called the Jones polynomial. If we can use cluster algebras to show that the A-Polynomial is connected to the Jones polynomial, we will have answered a question that people have been trying to answer for over a decade. And all this comes just from thinking deeply about a piece of knotted string.